Meet the power button of the Philicorda organ. Beautiful, sexy style, electrical tube-based Philicorda organ. So very nice when the oscillators start to boot up. You can tell I'm not an expert organ player, but this is just to show that the keyboard works again, which I'm quite glad about. So the purpose of the video was just to take a look inside the organ. Some very nice electronics in there, and I had to do a bit of a cleaning up of the keyboard mechanism for the thing to work again. It stood in quite a moist room actually, and I had some cleaning up to do. But it's a really nice piece of equipment, and I just had to do a bit of painting actually inside the keyboard mechanism to get everything working again. As you can see, the mechanism works again. It didn't work at all on the electronics themselves, and if you listen closely, I just had a very simple mic setup there on the side on the loudspeaker, but you can hear a lot of hiss, of course. And I also managed to mess up the power button when I put the thing back together, which I need to fix later on. And I really like the sound of the oscillators turning on. You can see the setup with the mic on the side, not even aligned. What an amateur job. Oh well. But here we are under the case, under the organ. Very, very simple to get at the actual mechanism. I had to take apart the whole thing to clean the keyboard, the keys themselves. But to get at this actual mechanism, it's also very easy. Well, taking apart the keys was also easy. I'll get to that later on. But this is really, really easy and easy to maintain. Just a beautiful sight to see. And you can see me pushing on one of the mechanisms. You can see the blank wires coming there, 3 wires per key, at some points 4 wires per key, and you can see the black wires, which look like they are normal plastic insulated wires. They go from one side to the other, and they are electrically connected, of course, to the rest of the circuit. And the thing is, the mechanism works like this. You push the keys push on it, and then the blank wires touch the black wires underneath. And you can see me pointing with the brush inside it, because I actually had to paint with this brush. I had to paint some graphite, some conductive coating on the black wires, for the so that the resistance goes down when those blank wires make contact with the black wires. I'm not surely not perfectly explaining this mechanism. I still have to do some research about this actually, and you can see me there doing some measurements on the resistance. You get about between 1 and 1.5k of resistance, but it's not a distance, it's not a mechanism that works with distance, and you'll see in a second that it's really about the signal itself. And here's me taking a sip of coffee and getting back to work with the oscilloscope. After some fiddling around, I just took a few measurements of one of the, I believe the top row probably. So what you see when I push a key is the actual signal that is passing through the black, the coated wire, so to say. And you can see that it's a nice sawtooth wave at almost 2.5 kilohertz there in the upper octaves. Almost regular, no, pretty regular sawtooth wave. And there you can see one of the other wires which I measured underneath, and you can see that there's something at the zero crossing going on there, another spike, maybe some bias to adjust, something to look at in a further video maybe. And this is actually the same key, I believe, if I'm not mistaken, almost the same key, at 1.24 kilohertz, so more or less half of it. And then there is the third row. You can see again 3 spikes per cycle at 414 hertz, 415, and yeah, you can see some other signals there in the sawtooth wave. There's a lot more to explore there, I'm sure, in further videos. In the meantime, I took a reading of took a small FFT, and you can see how beautifully the fundamental is on the left, and then the harmonics actually go up in the noticeably go up to 40 kilohertz probably. So you can see my reading there, which goes from 0 to 100 kilohertz. Very nice. And there, this is actually the bridge where the switches and rotary knobs are on there. This is kind of like a bridge which goes from right to the left of the chassis, which you can also very easily take off 1 or 2 wires. And I didn't do a lot here, just cleaned the knobs and cleaned up the tubes, which are shiny again. And there you can see the beautiful horizon of oscillators with their, I believe, which are some tunable inductors at the end, I don't know. But you can see notes of the individual tones that come out there still sticking on there. You can see an F and a fizz, so F sharp, and the tubes, of course, which were not so easy to clean there in that state, but a very tidy and symmetrical circuit there. Very nice. The transformer, the power supply in the back, and there's actually one thing I really was surprised about. Really nice to see. I only had to remove 2 screws, and I noticed at some point that there's some kind of like a hinge mechanism. I thought, what's this about? And you can just pull this up and look how perfectly you can get to everything. It's just, yeah, beauty. And some transistors there, very nicely suspended reverb tank that's perfectly swinging. And also in the back you can see this beautiful technical drawing. So that's about it for this very short first video about the Philicorda. I just wanted to say a few words on the keys themselves, on the mechanism. So if you ever find an old organ, an old piece, an old keyboard, and you have some keys that seem to sometimes work, sometimes don't, look at the mechanism. If it's one of these kinds with conducting wires or conductive coating, just get your brush out.